look at these last few examples, there seems to be some sort of pattern here with how we go from our division statement to our answer. And when I look at this one, example 3 here, it looks like for some reason the divide here, this 1/3, the 3 ends up on the top, and we end up with 3/4. Looking at this one here, if I did the same thing, our divide here, divide by 1/2, this seems to come up to the numerator, and 2 divided by 8 is same as 1/4. And taking a closer look at this one, we can, if we actually kind of flip this fraction, we can have a times 3 on top, divide 2 on bottom, and it looks like we end up with 3 on top, and then 6 times 2 on bottom, so 3/12, and that ends up being the same as 1/4. Now, maybe I'm not too sure if you can follow what I'm doing, but it looks like if we flip this fraction and just multiply, it seems to be giving us the same answer. Now, that would be very convenient if that actually works. So let's investigate to see if that actually works. So when we talk about fractions in general, this is a good generalization. The top is multiplication, so anything we put in the numerator is multiply, and the bottom is divide. So when we multiply two fractions together, really as long as the top is multiplication, we could just do top times top, and since both bottoms are divide, we just keep them in the denominator and we do bottom times bottom, and that gives us the right answer. So we had 5/4 times 5/2 is going to give us 20/10, which is equal to 2. So as long as we're keeping the top in the top, the times on the top, and the divides on the bottom, we're going to get everything fits our model of fractions, times on top, divide on bottom, and we get the right ratio. So how do we justify this flipping of this fraction when we have divide? Okay, so if I'm going to do 5/4 divided by 2/5, okay, so if I draw my 5/4 fraction here, sorry, my 4/5 fraction and my 2/5 fraction, so here's my 4/5 fraction, there's 4 pieces here, and I have 5 2/5 in the denominator. Okay, so make that. And we can clearly see that this is a 4 pieces to 2 pieces ratio. So we know that this must be a 4 to 2 ratio, and the answer must be 2. Okay, the picture doesn't lie. We know the correct answer must be 2. So how do we justify that if we flip this fraction and multiply, we get the right answer? Well, if we think of everything as times on top and divide on bottom, and we actually read this statement, this means times 4 divide 5. And if I look at this fraction, this really means divide. Okay, so if I read this as a sentence, this means divide by 2. So this together means divide by 2. Well, really, that 2 is divide. That means the 2 should end up in the denominator here. That makes sense. Okay, I'm just going to highlight that. The 2, because it says divide by 2, should end up in the denominator when we put it into a fraction. What about the denominator here? Well, what does this really mean here when I look at the statement? So if I read the statement, it says divide and then divide. There's another divide there. There's 2 divides. Okay, I'm just going to highlight that. This is divide and then another divide, and we're dividing by 5. Well, divide really means the opposite of multiplication. Here we have the opposite and the opposite. Well, opposite really means to do the same thing. So divide really means multiply. So if that's true, then this 5 really is not a divide by 5, it's a multiply by 5, which really should end up in the numerator. So what ends up happening then is, if I just put my times and divide in the right places, that really divide should go on the bottom, that divide should go on the top as multiply. If I just flip this fraction, I really put them in the right positions when we talk about fractions. And it's to do with the second fraction here. I'm really flipping that second fraction to get the times in the right spot and the divide in the right spot. So the rule then is, if we flip the second fraction and just multiply, we're going to actually put the times and divide in the right places, and then we can just evaluate this fraction as one big fraction, as 4 times 5, 5 times 2 in the denominator. Sorry, 4 times 5 in the numerator, 5 times 2 in the denominator. So the rule then we can use is, we can multiply by the reciprocal of second fraction. So when we have divide, we can just change it to multiplication, because really we want multiplication, because division, the fraction really is just times and divide. So if we multiply by the reciprocal, we've done the opposite. So multiplication is opposite of our division, and the reciprocal balances that opposite. So anytime we do an opposite and we balance it with another opposite, we're actually doing the same thing. In math, that's a general rule we can have. So opposite in math is back to the same place. So this is what we're doing. Instead of dividing, we're going to do the opposite multiply. And to balance that opposite multiply, we're going to flip the fraction or the reciprocal. So we exchange the times and divide of that second fraction, and that gives us a much easier way to divide fractions. We can just change it to multiplication. So when we have this here, we can try this. So let's try this. We're going to do 1/3, and we're going to do the opposite times. And to balance that opposite, we're going to do the opposite. We're going to flip that fraction, the second fraction. And so we get 2/3 as our answer. Now when we look at the picture never lies. If I look at my 1/3 fraction, there's 2 parts here. And I look at my 1/2 fraction, I can divide it into 3 parts. Yeah, it looks like there is a 2:3 ratio. And again, the picture doesn't lie, so we know that this must be correct. And it matches our answer when we change our division to multiplication and balance that opposite with another opposite by flipping that fraction.